Hello students, now we'll go to the subsection, that is the next subsection of the 6th program, that is 6b. Now 6b is a YAP program in order to recognize identifiers, operators, keywords in a specific input file. So with a given C file, you should be giving an input file as a C program. Now in that you should recognize what are the operators, what are my digits, what are my keywords and what are my identifiers. I have taken the same v.c, 6a whatever we discussed after removing the command lines. I have taken the same v.c file as my input file. Now we'll see the program of the YAC program of 6b. Now in order to write the YAC program, first I should be writing the LEX program. So 6b.l I am using it. So 6b.l I am identifying the tokens. What are my tokens here? Actually I should recognize my operators. So my operators are plus, minus, star, divide, equal to, less than, greater than, etc. You can have any number. I've used all of these in random order. So whatever that's been matched in my input, that will be stored in YY text. So by default it will be as a string, so that's why a %s. So for this you're returning the token name as OP. Now if you want to recognize digits, it can be any number of digits from 0 to 9. Any number of digits repeated for n number of times, one or more time. So that's why the regular expression plus. As every matched expression will be stored as string in YY text, that you should be converting into a number. So that's why a YYLVAL, again a LEX library function. So for this you can use %d here and return the token name as digit. Now if any other keywords, any other matched keywords like print, int, char, bool, float, void, for, do, while, if, else, etc. All of those are keywords, again matched keyword present in YY text used as a string or accessed as a string. I am returning the token name as key. Any other characters from A to Z or capital A to Z from 0 to 9, any number of times if it's been repeated, this if it's matched, stored in YY text, accessed as a string. So I'm returning the identifier as token name as ID. Any other single character matched, don't take any action. The action is semicolon. Now if you see the YAC part, that is the 6b.y, if you start from the main function, again you're using the file, say aa.c, you can use v.c as well. So I changed the file name to v.c. Now if this file is not present, you will return it as a statement as a can't open. You will return the value as -1. Otherwise you will point the YY in, that is a LEX defined specific pointer, LEX defined pointer YY into the pointer my file. My file will be pointing to v.c. YY parse, again construct starts building your parse tree or your syntax tree. Now we'll go to the definition section. All of the counts of identifier, digits, keywords, operators, they are initialized to 0. Each time if you encounter, you should increment the count as well. Now the tokens returned from LEX are digit, ID, key, operators, etc. Now if you encounter digit, ID, key, that is digit, that is this part, that is digit, ID, key and operator. If there are only one encountered value of digit, ID, key, operator, etc., increment those counts respectively. Now digit can be followed by anything, that is digit can be followed by keyword, operator, ID, etc. Similarly ID can be followed by anything, that is keyword, digit, operator, etc. Keyword can be followed by anything in the sense digit, ID, operator, etc. Operator can be followed by again digit, keyword, ID, etc. Now these repetitions should be again shown recursively. That's why I am using the start symbol recursively. But the starting here is digit, so that's why I have encountered the value as digit. This input can be anything here. It can be followed by digit, followed by ID, followed by keyword, etc. That is followed by ID, keyword, operator, etc. So this entire rule section suggests you it can be starting with a digit, ID, keyword, operator. It can be only digit, ID, keyword, operator or followed by anything else. That is recursively I have repeated these symbols. So if such grammar, if you are able to construct, then you are successfully displaying what are those numbers, what are those counts of keywords, identifiers, operators, digits, etc. Otherwise, if you are unsuccessful in this, you will go to YY error. That is, if the parse tree construction is unsuccessful, you will go to the display of a function YY error, which displays a standard error message. Now I shall execute this, as it's both lex and yak part. Lex command in order to convert lex program into a C file. Yak program, that is yak command, with -d as the option to access the token codes along with the token names, because token codes are accessed in order to access the token names. So yak followed by the file name. Now both are converted to C files. So lex.yy.c is from the lex command, and y.tab.c is from the yak command, -ll for the lex library. Now there are no errors. I can directly go on with /a.out. A.out. No need to specify the file name, because file name I have already given as the parameter in your main function, that is your argument in your main function, that is v.c. So according to v.c, our v.c file alli, what are the keywords, identifiers, what are those? So void is a keyword, main is an identifier, float is a keyword, a123 is an identifier, etc. All of those counts are also displayed. How many number of digits, how many number of keywords, identifiers, operators, etc. All of those are displayed, along with what are those. Void, what is it? Main, what is it? Float, what is it? Is it a keyword, etc. Char, what is it? Even they are recognized depending on your rule section of your written lex part. If the rule section has all of this, it is recognized. Otherwise, you need to add some more rules. If there are any other if any other symbols that needs to be recognized in your program, you need to add your rule section part in order to be able to recognize what are all those. So I hope you understood the logic of 6b. Thank you everyone.